he's going to pull up the CAD file and he's going to hit print, and he's going to print a new car part. And this is further down the line still, but it's going to happen. Ford has some prototype development centers. So just about every car part is prototyped at one point or another using a higher end 3D printers, be it stereolithography, selective laser sintering, selective laser melting, some voxeljet printing or X1 printing, which prints the sand mold, similar to what's on this table behind us. We'll actually print a sand mold to cast metal parts. So if you want to cast a new engine block, before you go cut millions of dollars worth of tooling, they'll print a mold out of sand in a couple of days, and then they can take it to the foundry and pour metal in it, and they can see, oh, wait a minute, I need to change this thing, and now they spent $1,000 instead of $1 million in tooling.
So these parts you're not going to buy in your house.
So is this using your 3D printers?
Right.
And they're molds, right, for parts?
Right. This here is a sand mold. It's a half-scale version that was used to cast this 2-liter EcoBoost cylinder head.
Cool.
So this mold is 3D printed directly, no tooling to make the part. Printed sand and foundry binders. Right. Then we'll take this to a foundry, they'll pour the molten aluminum into it and create the cylinder head.
Does that speed up the process of developing the part?
Absolutely.
Because you don't have to...
You don't have to machine the tooling to do this, which is several weeks to a few months to machine tooling to make this. I can print this up in a day or two. Take it to the foundry, make the casting. And if the engineer says, well, I don't really know exactly what my design wants to be, I've got like 3 or 4 versions of this thing. Well, if he's doing tooling, he's only going to do one. I can print all 4, 5, 6, whatever he wants all at the same time, cast some cylinder heads, have them to him in no time.
So you think the car dealers will actually print parts at some point?
Eventually, yeah, it's going to happen. Not the car dealers.
Right.
I think it's going to be more of a hub.
Yep.
So a service parts organization somewhere out there is going to have a bank of these machines printing parts. Now it's going to be a metal part or a higher level plastic printer at the time, but eventually it's going to happen.
At some point, you actually might be printing parts at dealerships. Do you see it going down that road?
There's always potential to make parts, right? But again, a company like Ford, we have to think about liability and what parts we would allow people to make themselves. Suspension component, no, I don't think that's going to happen anytime soon, but maybe, I don't know, maybe a spoiler or something that has, no effect, a piece of trim, I could see that coming.
Well, tell me about the 2 printers here.
Okay.
So the first one is this one printing the mold, right?
Yeah, this is a Cubix 3D printer. It's a deposition modeling. It basically takes wired plastic or line plastic, and we're heating it up through an extrusion and layering it layer by layer in a position to create our part. So what we do is we'll start at the bottom layer of this part and we'll print this layer. The platform will drop down slowly. We'll do the next layer on top. Drop down a little bit, we'll do the next layer on top, and we'll print this exact part. Now, one of the neat things about 3D printing and additive manufacturing is we can do things that you can't do traditional machining, milling.
Yeah, show me the belt. That's kind of cool. You've got a belt that you actually printed as is, right?
Okay, this belt is a designer belt, and I'll give the designer a little nameplate there. He designed it and sent it to one of our printing labs and said, I want to have several of these made. Online, you can go buy his designs. This was printed on a technology called selective laser sintering. And what it does is it takes a bed of fine plastic powder and we hit it with a CO2 laser and melt the shapes of each part as it is. Now the reason it's functional, it's movable, is there's a gap between it. So if there's a gap between the part, we don't hit it with the laser beam. This prints rather fast, and we probably printed a bunch of them like this in a platform overnight, and then you dig this part out, and it's like you're digging a part out of the sand at the beach.
And it all works.
And it's functional. You clean it up, you rinse it out with some water, and it's like this. It's white. Obviously, they wanted a color, so they dyed it red for this, but it could come in, you can dye it in any color you want.
And what do these printers cost? So how much is this one over here?
This printer, these are consumer product printers. This printer goes for just under $4,000. Available on Cubify and 3D printing lines. And here's a cube, which is more consumer products for your home inventor, your students, your college students, people trying to get into this and sell it. That's for under $1,300. The whole idea is that the more people that have these in their hands, the creative ideas that they have in the back of their mind, they can bring out and get to the world. Maybe someday some guy's going to print a heart valve on it.
My question for you is, how much, like a regular printer, it's not the printer, it's the paper and it's the toner. How about the plastic that goes in it that actually creates it?
Inexpensive in the scheme of things. More expensive than injection molded plastic because they're building it by the train loads full. Obviously, we're selling it in small containers. These cartridges are only $90 a piece.
That's not bad.
Not bad at all.